So let's take a look at how to find the answers to these questions. What we're going to do, first of all, is make an assumption here. And the assumption is that we are quite comfortable dealing with exponents. I'm going to do a quick reminder of the rules that we're going to be using today. All right. So very quickly, we know that if we have a situation a to the x multiplied by a to the y power, because they have the same bases, and these are the bases, okay? What they're raised to is the power or the exponent. So we have the same bases, then what we can do here is we can just add the exponent. So this will become a to the x plus y, all right? So these are your laws of indices, laws of exponents, okay? If they are being divided, a to the x divided by a to the y, again, take note that it's the same base. It's a to the something divided by a to the something. And all we do is we subtract the exponents. Keep in mind that there's an order, okay? There is an order, all right? We already know that a to the 0 power is equal to 1. We also already know that 1 over a to the minus x is the same thing as a to the x power. These are rules. These are the rules that we should have known, okay? The other one that you might see here is a to the x raised to the y power. So this is a little different than number 1 right here, okay? A little different than this. So a to the x raised to the y power, we multiply the powers. In the first one, we added the powers because it was a to something multiplied by a to something. In this case, it's a to the x raised to the y power. So this becomes a to the xy. Now, these aren't all the rules. These aren't all the laws of exponents, but these are the ones that we're going to be utilizing as we go through with these problems today, okay? So let's take a look at the first one. All right, so 2 to the x raised, 2 to the x is equal to 2 to the 5th power. And so the idea is we're going to try to solve for x, okay? So here's what we have to do. We have to realize that in this case, we have 2 to the something is equal to 2 to the 5th power. So they're the same bases. See, right here, the same base. So I can just equate the exponents. So I can simply say x is equal to 5. And in fact, that is correct. That is my answer, okay? But I can only do this because I have them both at a point where it's 2 to the something is equal to 2 to the something. So I can have the somethings, meaning the powers, equate to each other, okay? So we're going to see a little different when we move to the next question, right? So the second question here, very similarly, again, I have the same base. In this case, the base is 5, right? Then I have the exponents. So I can equate the exponents at this point. So I can have x minus 3, which is the exponent on the left-hand side, is equal to 4. Now I have to perform some algebra. So you have to recall now how to handle a case like this. I have x minus 3. All I want is the x by itself. So I've got to get rid of this minus 3 right here. So now when I do that, I have to transpose it, which means takes it to the other side. But the sign is going to change. So when it comes to the other side now, so what I'm going to have over here now is simply x. Taking this over here, I'll have 4 plus 3. Why plus? Because over here it was minus, right? So we're transposing, right? So again, what we're doing here is we're reviewing your ability to solve equations, okay? So the answer here is x is equal to 7. X is equal to 4 plus 3. All right, so let's move a little further. And as we go on, the problems get a little bit more challenging, but you have this video to always reflect back. Now, what I would do is, as I always do, when we're working these problems, I'm going to explain them, but you have the pause button so you can give them a try before you hear the explanation and test yourself out, okay? All right, so here we go. Now we have a different scenario because I have 2 to the something power is raised to x plus 3 is equal to 64, but 64 and 2 are not the same bases. They're not the same bases. So I've got to write 64 as 2 to the something power. Now, off the top of my head, I might not know that, but let me show you a little secret, right? Let me show you a little trick right quick, right? If we have 64, break that down until you can get it all in twos. And what do I mean? Well, 64 happens to be 16 times 4. Now, you could have seen that, maybe not, right? Let's find something you could have seen, because maybe you couldn't see that. No problem. No problem. So this is actually 2 times 32, right? That's 64. So now we want to break down the 32. Well, 32, so now there's 2. This is this 2. Multiply by this. So this 32 right here is 2 times 16, isn't it? 2 times 16. See that? And so we're breaking this down, and eventually you're going to realize that 16 is 2 to the 4th power. So I'm going to have 2 times 2, and this is 2 to the 4th power, which is 2 times 2 times 2 times 2. So this is all put together 2 to the 6th power. There's 1, 2, 3, 4, 5, 6 2's. Okay? So 64 is the same thing as 2 to the 6th power. All right? So now that I do that, I can now rewrite this as 2 to the x plus 3 is equal to 2 to the 6th power. I didn't change the problem, but what I have done now is I've created a scenario where I have the same base and there's nothing else on either side. So I can now equate the powers, right? So in equating the powers, what I'm going to have now is just x plus 3 is equal to 6. So this is power is equal to power because the bases are not equal. And again, I'm going to transpose because now my issue is going to be with this 3. Why is it an issue? Because I'm solving for x, which means all I want on one side is x by itself. So now I have x is equal to 6. And this is going to be minus 3 because in transposing, I'm going to change the sign. What sign am I talking about? Before I transpose on the left-hand side, this was plus 3. So when I take it on the right-hand side, again, this is transposing. I change the sign from plus to negative. Hence, this is become 6 minus 3. And so my answer is x is equal to 3 because 6 minus 3 is 3. Okay? Again, advantages that you have. You can pause the video before we begin. Try to solve it yourself. Go through the explanation step by step. And every time you see something where you may have gone wrong, you can pause the video and say, okay, this is what I should have done. Let me go back and try that. So those are advantages. You could do that. Okay? Also, you could just watch it twice. That's okay. Maybe you didn't get it the first time. Maybe you missed something. It's okay. Go back and review this. These are the advantages of recorded explanation. All right, let's try the 4th one. Okay, so here we are now. This is a little different now. Okay, remember, these are bases. So this is 3 to the x. It's not written, but this is really 9 to the 1st power, right? That's really 9 to the 1st power. This is 27, this is 3. So this isn't working for us right now. So what we have to do now is identify where we can have the same base. Because x is what I'm looking for, if I had everything in 3 to the something power, right, then I'll be better off. So let's start with 9. So right here, what I have here is 3 to the x multiplied by 3 squared, because that's what 9 is, okay? Now again, slight reminder, this is a perfect point to pause the video and try out the rest for yourself, okay? Assuming you did, if you needed to, and we're back. So now 27 is actually 9 times 3, which is 3 times 3 times 3. In case you can't picture what I'm saying, 27 is 9 times 3, and 9 is 3 times 3. And so 27 is 3 times 3 times 3, which is 3 cubed. So right here, I have 3 cubed multiplied by 3 squared. Now I want you to remember the first law. of exponents that I taught you / reminded you of when we began this video. When you're multiplying, if they're the same base, and see we have all the same bases here, what we do is we add the powers. Okay, so 3 to the x multiplied by 3 squared is actually 3 to the x plus 2. Remember, all we do is add the powers, add the exponents. It's the same base. We're multiplying, we just add the exponents. And that's the same thing over here, isn't it? Right? 3 to the third multiplied by 3 squared is just 3 to the 3 plus 2. So what we really have here now is 3 to the x plus 2 is equal to 3 to the 5th. And now we're in a place of comfort, aren't we? We have 3 raised to something is equal to 3 raised to the 5th power. Same base, so I can just equate the exponents. X plus 2 then is equal to 5. Of course, I have to do something with this 2 here. It's in my way. So I have to transpose it, and when I do, take it on the other side, it's going to become minus, because over here it was positive. So x is equal to 5 minus 2, hence x is equal to 3. And that's my answer. Okay, so you should be feeling pretty good about yourself right now. Right, and we're going to move into number 5. However, number 5 is just a challenge question for you, kind of like homework. Okay, so you get to solve this one on your own. What I'm going to do is I'm going to put the solution to this down in the description of the video, so you can go ahead and try to work it out and then check your solution in the description of the video. And I hope this video helped you out a whole lot. There are lots of videos like this on my channel. Down in the comment section, let me know what you got for your answer if you did not get the right answer, and I will gladly show you how to do it. Okay, I hope you liked the video. Share the video. Have a good one. Other videos in this and other series are available. Like, share, and subscribe if you found the video helpful. If there's a topic you'd like to see us tackle, just let us know.